Hello everyone! Today we're going to be learning how to solve revolution problems. And so basically revolutions are used to solve for volume, which is the three-dimensional use of integration as area under a curve. So basically, the area below the curve and above the x-axis can be approximated using the rectangular approximation method. Then, if each of these rectangles is revolved around the x-axis, the second figure right here is produced. Now we could find the volume of each cylinder and add them together, which is fairly simple, but the approximation of volume will improve as the number of cylinders increases, which is seen here. Therefore, we allow the number of cylinders to approach infinity, and with that, the delta x goes to 0, making the cylinder into a circle. And from this process, we get the equation volume is equal to pi integrated from a to b of f of x squared dx, which is integration of area of a circle, which is pi r squared, with the f of x being the radius. This will make more sense with an example. So, example problem 1. Determine the volume of the solid obtained by rotating the region bounded by y equals 7 minus x squared, x equals negative 2, x equals 2, and the x-axis about the x-axis. So, in this problem, we're given the bounds from negative 2 to 2, and if we weren't given those, we would find the interval by setting the equations given for the bounds equal to each other and solving for x. And in this picture, we can see that the radius from the x-axis up is y equals 7 minus x squared. And if we plug that into our area equation of pi r squared, we will get pi times 49 minus 14x squared plus x to the fourth. And from there, to find the volume, we're going to integrate from negative 2 to 2 as given in the original problem. And to do that, we just find the antiderivative of this whole function and evaluate at 2 and negative 2. So since 2 is the upper bound, we begin with that. So we plug in 2 at each x and negative 2 at each x and find the difference. And you can see that in my work here. And you can watch the process of how I solved and found like denominators and got the answer of 2012 pi over 15. Now on to the next problem, example problem number 2. This one is a little different because we have a washer in the middle, and a washer occurs when rotations result in a solid with a hole. And in this situation, rather than using just one integral, you will use 2, finding the answer as the volume of a solid minus the volume of the hole. And that is seen with this equation right here, where r, big R, represents the outer radius, and small r represents the inner radius. So since the original problem did not give us our interval, we have to find them through intersection. So intersection, we will just put each function equal to each other. So y squared minus 6y plus 10 equal to 5, since both are in terms of x. And then solving that, we get y equals 1 and y equals 5, which gives us these 2 points, which can be seen on this photo. And from that, we get that the big R, the outer radius here, is 5 from the y-axis, since we are rotating about the y-axis. This whole thing is 5. And then at any given point, 2, this will be the function, which is the inner radius. And applying that to this equation, we will get pi from the outer radius minus the inner radius, and that gives us our area right here. And then we will integrate from 1 to 5, so just find the antiderivative and input the values of 5 and 1 into the function. And you can follow my work to figure out how to get the answer of 1088 pi over 15. And one more problem. Example problem number 3. Determine the volume of the solid obtained by rotating the region bounded by x equals y squared minus 4, and x equals 6 minus 3y about the line x equals 24. Why this one is different from the other two is that rather than rotating around the x-axis or the y-axis, we are rotating about a line, and that line is seen right here. So once again, we have to find where the points, or not the points, the functions intersect in order to get our interval. So we have y squared minus 4 equal to 6 minus 3y, and as we solve that down, we get that y is equal to negative 5 and y is equal to 2. And you could see that here, negative 5 and 2. And the reason this isn't on the x-axis and it is on the y-axis is because we have the functions in terms of x rather than in terms of y. And so solving, first we find the big R and the little r, so outer radius and inner radius. And we can see here that the outer radius is going to be from 24 up to this blue function, which is y squared minus 4. Thus, big R is 24 minus y squared minus 4, which will just be simplified to 28 minus y squared. And same thing for little r, the inner radius. It is going to be 24 up to this red function, which is x is equal to 6 minus 3y. So it is 24 minus 6 minus 3y, which simplifies to 18 plus 3y. And now to find the area, we just plug it into pi r squared using big R and little r. So big R squared minus little r squared. And when you simplify that, you get this function. And moving on, we find the volume by integrating from negative 5 to 2 like we solved over here, and taking the antiderivative and just plugging in these 2 points. First the 2, then the negative 5, since the 2 is the bigger number. And it is just clockwork, so I didn't put the actual work here. But if you do this by yourself, you would be able to get this answer. So I suggest you pause the video, solve the problem all the way through, and see if you get the same thing. And if you don't, figure out using the other problems what happened to your work, because the work should be simple algebra from the point you plug in these two. And now we're going to go over a few common mistakes. So the first one right here is that not multiplying by pi at the end. So a lot of people, when they're integrating, they focus on this part since the pi is normally taken out and put on the side, and then at the very end they forget to multiply it. So make sure not to do that. And then the second one here is when you have a washer, instead of squaring the whole thing, it's r to the second squared minus r to the first squared. They're separate. They're not put together, because that will give you the wrong answer. So make sure not to do that as well. And then another one, if R1 is larger than R2, then you cannot subtract R1 from R2. So, because that will give you a negative volume, and that's impossible. So basically, at the end of every problem, you should double check to make sure that you have a positive answer and that you have pi at the end. That's very important, because if you didn't, then you're missing something, and it could be really simple, like you just forgot to multiply by pi, or you just switched up these two. So make sure not to do that. And the last common mistake is mistaking the axis or line of revolution. So if the problem is asking you to rotate about the y-axis, and you mistaken it and accidentally do the x-axis because you're used to it, or it's easier for you, or for some reason, then that will obviously give you the wrong answer. So make sure you're listening to directions and reading the problem carefully and thoroughly, and if you do that, you should be able to get everything correct. So I hope this video helped you out. If you need extra problems, feel free to click the link in the description, which will send you to a worksheet with extra problems and solutions. And thank you for watching my video. Hope it helped you out. Bye.